The next form we are going to talk about is something called slope-intercept form. And I apologize in advance if this is a little bit shaky. I'm doing the best I can using my phone to record this. So you can still kind of at least hear me explain everything about slope-intercept form. So slope-intercept form looks like this. Y equals mx plus b. Or you might hear this called y equals ax plus b. Depending on who you talk to. But really, either way, it is the same thing. Y equals mx plus b is probably the one that I'm going to use more often. But in this form, we still can see some pretty important information. With standard form, we could figure out the x and the y intercepts pretty easily. The really good thing about slope-intercept form, kind of like the name says, is it's pretty easy to find the slope of the line and also the y-intercept. So looking at this equation, we figure out the slope by this m value. Okay, and the m, if you look at how that looks like in your equation, the m, the part that tells you the slope, is the part that's attached to the x. That part is really, really important as we go through. And then this b value at the end is the y-intercept. That's the b value. Okay, so really, like I said, you can use either form here, mx plus b or y equals ax plus b. Same thing, I'm just going to kind of stick with this one. But know that like if you ever hear y equals ax plus b, they're really talking about the same thing. So what actually is slope? When we were talking about how to tell if something was linear or nonlinear, we checked to see if there was a constant rate of change. That's what slope is. Slope is the rate of change. And when we talk about slope, we're really finding the rise over the run. How much your y values change up and down versus how far they change left and right. We'll learn more about slope later on and talk about, I guess at the beginning of our next chapter, how to find the slope between 2 points. But for now, knowing the slope is the rise over run is the really important thing for us to know. So there are 4 possibilities for what slope could be. We could have a line with a positive slope, and the slope, if it's positive, is going up, like you're climbing uphill. You could have a line with a negative slope, and that negative slope, the line is going down, like you're falling. And then the other 2 options are kind of weird. These are those ones where we have a horizontal line or a vertical line. Whenever we have a horizontal line, the line slope is 0. Okay. I'm going to add the note here too, that if we have a horizontal line like this, remember that line looks like this, y equals 3 or something like that. Y equals a number because that horizontal line, it crosses the y-axis. And then if we have an undefined slope where that line is vertical, that's like the line x equals 2. X equals because that letter tells us what axis we cross. Okay, so keep these 4 possibilities for slope in mind as we go. Now, if I take a look at this graph right here, this is the graph of the line y equals 2/3 x plus 2. Let's take a look at how these pieces fit together. That 2, notice how it's a positive 2? That's the y-intercept. And notice how that graph crosses the y-axis at 2. The 2/3 is the slope. Okay, matches up here where the slope is the number in front of the x. That's the 2/3 in this case. The 2/3 is our number in front of the x. What that means, rise over run for your slope. What that means is that we go up 2 when we go over 3. And let's look at our graph. If I start at our y-intercept here, we go up 2 when we go over 3. And look, hey, there's another point. If I find another point down here, if I go up 2 over 3, I get to another point. Okay, so we're going to kind of work through this process backwards when we're graphing. Just to see one more situation. Right here, y equals negative 2x minus 1. That negative 1 is the y-intercept. And then right here, the number in front of the x is the slope. Okay. And take a look at that number too. Notice how that slope is negative. That negative slope, right up here, this negative slope, our line is falling. Negative slope, the line is falling. So the slope being negative 2 over 1 is, the slope being negative 2 is really the same thing as negative 2 over 1. And that's going to be helpful for us, especially when we go to graph, that we go down because our slope is negative, down 2 when we go over 1. We go down 2 to go over 1. Down 2 to go over 1. All right, so let's do some work with identifying slope and y-intercept from equations. And then on the back side, we're actually going to graph some lines. So our first situation down here, we are going to identify the slope and the y-intercept from each equation. Our first equation, we're going to do y equals 2x minus 6. Now the slope is the number that's in front of the x. If you compare up here, y equals mx plus b, the slope is the m value. So the slope is the number that's in front of the x. Our slope is 2. And then the y-intercept is the b value. It's the number that's at the end. If I look at what number's at the end here, be really careful because this sign, this negative sign, is attached to the 6. So our y-intercept is negative 6. Another one, if I look at y equals x plus 4, again, finding the slope and the y-intercept. The slope, I need to see what's the number that's attached to the x value. Well, there's not a number written. Remember that that number is really like there was a 1x there. So that slope is 1. And then our y-intercept, the number that's by itself, is 4. All right, so let's flip this over to the back. And we are going to graph an equation from slope-intercept form. And then we will do a couple extra examples after that. So our first equation we are going to graph, let's graph y equals 1/3 x plus 3. The first thing that we want to do is to find the y-intercept. And in this case, 1/3 x plus 3, the y-intercept is 3. So what I'm going to do, find that y-intercept. We found out it was 3. We are also going to plot the y-intercept. So this is all together in step 1. We're finding the y-intercept and then we're going to plot it. We're going to put a point there. Y-intercept happens right here. After that, our step number 2 is we want to identify the slope. Slope is always the number that's attached to the x. In this case, that's 1/3. And along with identifying the slope, we also want to think about how that's going to look for our rise over run. So that 1 is the rise. The 3 is the run, the horizontal distance. So we're going to go up 1 every time we go over 3. Which leads us to step 3, where we're going to use the slope to plot a few more points. Ideally, we at least have 2 more points on there. So use the slope to plot 2 more points. From the y-intercept. So we start off on our y-intercept, and then we use the slope to get a couple more points. Now our slope was 1/3. So what that means is we're going to go up 1 over 3. Up 1 over 3. Up 1 over 3. Now you don't really have to keep going with that 4th point. Usually though, the more points that you have on here, the more accurate your line will be, just because then you're going to make sure that you're drawing your line through all of those points. If you wanted to, you could come back this way also. But to go up 1 and over 3 from wherever we are over here, we're going to go the opposite direction. Down and left. Down and left. Okay. But after that, that leads us to our 4th step, where we connect the points. Now when you do this, you're going to use a straight edge, which I'm going to set my phone down just for a second so that I can do that. Okay, and your line should look something like this. You see how we have a positive slope because our line is going up. That double checks with what our equation looks like, where we had a 1/3 in front of our x right there. Let's just do one last example right below here. Let's graph y equals 2x minus 4. So our first step to graph is to plot the y-intercept. Find the y-intercept and plot it. The y-intercept, the number at the end here, is -4. So on my y-axis, I'm going to go down to -4. And then step 2, identify the slope. Which in this case, our slope is 2. To figure out how on earth we're going to graph that slope, think that slope of 2 is really the same thing as 2 over 1, because that makes it a lot easier to think that 2 is the rise, the 1 is the run. Otherwise, if you just see the 2, it's kind of tricky to think, well, how far up am I going and how far over am I going? We're really going up 2 and over 1. So from step number 3, from the y-intercept, we have to plot 2 more points at least using the slope. So we start at our y-intercept here. Our slope is 2, so we go up 2 over 1. up 2 over 1, up 2 over 1, and really you could keep going if you wanted to. We just want to make sure we have enough points here to make sure that we're getting a good picture. And again, I'm going to set my phone down here so I can connect my points with the straight edge. But your graph should look something like this. So the rest of class, you guys have an exit ticket to do, and then also have a worksheet that you guys can work on. So good luck. I will see you tomorrow. I'm home with a sick kid today. Otherwise, I would be there. So good luck. I'll see you tomorrow.